Here's a lesson on slope-intercept form. So linear equations can be written in the form y equals mx plus b, where m is the slope, which is going to be our rise over run when we look at a graph, and b is the y-intercept, which is the point where the line crosses the y-axis on our graph. Okay, so let's take a look at a specific example. If we're given the equation y equals 2x plus 1, we notice that our slope is 2 and our y-intercept is 1. So we can write m equals 2 and b equals 1. My slope here is 2, so that means when we look at the graph, the rise over the run equals the value 2. But if we notice, rise over run is written as a fraction, so I need to change my whole number to a fraction. So any whole number can be written with a 1 on the bottom, so this fraction will be 2 over 1. Or I can also write that as negative 2 over negative 1, because a negative divided by a negative will give me a positive. Okay, now let's look at the y-intercept. The y-intercept here is 1, so I know that the coordinate point here will be 0, 1, because our x value for any y-intercept is always at 0. Why? Because the y-axis is at the value of x equals 0, so any point on the y-axis has to have an x value of 0. So this particular coordinate point is at 0, 1. So when we graph our linear function here, we'll start off with the y-intercept. So the y-intercept, we're going to go to 0, 1 on our graph and go ahead and plot that point. And then from our y-intercept, we'll use our rise and run to create the slope of the line. So for this one, we're going to rise a positive 2, so we're going to go up 2, and we're going to run a positive 1, which puts us going right 1. We can also go in the opposite direction by rising a negative 2, which means I'm actually going to go down 2 units, and then run a negative 1, which puts us left 1 unit. So if we connect the dots, we create our linear function. So this lesson was on slope-intercept form.